Hello everyone, today we'll be doing the Euclidean geometry part theorem 3. It says the angle at the center is equals to 2 times the angle at the circumference. This is a short a short information about this theorem. So basically, what do we mean? Let's just say I have my circle here, my beautiful circle there, and then I have my, check this thing here. It is the easiest because many people like it. Okay, and then I have my angle here, and then I have my angle there. So what does this mean? I want you to be careful there. Please be careful there, right? So it simply means if I have O here and I have A there, if here I have 2x, it means what at A I have what? X. I hope you now understand it. The angle at the center is equals to 2 times the angle at the circumference. You see, it is what they say, 2 times the angle at the circumference. 2 times the angle at the circumference. The angle at the center, which is this one, it is equals to 2 times. What is 2 times x? It is what? 2x. That's what it simply means. Okay? Or the angle at the circumference is half the angle at the center. But that one is confusing. Angle at the center twice at the circumference. This is how it can be represented, whereby we have a line going down and up. You see? And then it can be represented like this again. It can be represented in many ways so that they can confuse you, but you have Pontos tutorship. Everything will be okay. So it can be also represented like this. This is my center, right? And then it can be line that is drawn like this, and then there is a line that can go like that there, and then an angle going like that, and then another angle that is going like that, whereby this is still my 2x, and then this is my what? X. You see, it is not something difficult. It is not, because the two lines are going there and then going up there again. You see, it is going down, going up, going down, going up. You see, the two opposite, okay, the two lines, like the line in the left hand side and the line in the right hand side, they both go down and then up at the same time, go up, and then they meet somewhere. You see here, right, left, they go down and then they meet there up. This line and that line, they go down and then meet where? At that other side. Okay, and then again it can be represented like this. But this one is more complex because this is a cyclic quad. It is something like this, whereby I have my 2x here, not inside, outside 2x, and then it is my what? X here. This is still my center. You see, that's how it works. So this one, it is about revolution. But you will take it when we are gonna be doing examples. And then the last scenario, it is like this, okay, where I have my line there, which is the center, and then manje I have a line like this, which is the same as a diameter, but manje I have something like a isosceles triangle, so it is also the same thing here. So whereby I have my 2x there, and then I have my x there. That's how it goes. You see? Yeah, I hope you understand me now. The two lines, they go down and then they meet there up there. So this one is kind of tricky because it is like you won't always see it, but the most common one, it is this one and this one. Okay, so let's continue, guys. The angle at the center is 2 times the angle at the circumference. It can be represented like this and like this and like that and like that. Okay, so the angle at the center, which is 2x, it is 2 times the angle at the circumference, which is x. 2 times x times 2, it is 2x. So something like that. Okay, so that's how it is, guys. The angle at the center is 2 times the angle at the circumference. So now let's check the proofs. Everything has its proofs. Before we move, let me label this what you call, let me do a different one like this one, and then I have my thing here. Okay, and then manje I have C here, and then manje I have A there, and then manje I have B. Ne? So maybe then I can say I have O. So what can I include? I can say angle AOB, it is 2 times ACB. Okay, yeah, just like that. So let's go to the proofs, guys. So here's a proof, guys. They're saying prove that angle A, so this is my O there, angle AOB, it is 2 times the angle ACB. Okay, so now the first thing that you're gonna do, let me just construct. You know, the first thing, it is construction. You know, construction. Whereby I'll have to construct a vertical line, which is what? OC and OA. The line that must be like this, which must cut the triangle into 2 parts. Okay, so it is construction. All right, let's move on. Let me add this thing. It can be D. So I'll have to construct that. So it can be construction OC and OD. Okay, so I'm done. So let's continue. The first thing that you can do, proof. This is the proof. We are starting now. Be careful there. Watch, learn, memorize. So I can label it as O1 and O2, and then C1 and C2. The proof is starting right now. What I will start with, I will start by saying what? OA, it is equals to OB. That's it. OA, it is equals to OC. Okay. OA, it is equals to OC. I made a mistake by saying OB. So OA, it is equals to OC. Right? So what is the reason? A radi. A line from the center to the circumference is a radi. So the line from the center to the circumference is a radi there. Okay? Then I'm going to continue. So I'm going to say angle A1, it is equals to what? Okay, no, angle A, it is equals to C1. Angle A, it is equals to C1. What is the reason? It is the what? Angles opposite equal sides. So angles opposite equal sides. Because this is a isosceles triangle, guys. All right, and then I'm gonna continue. I'm gonna say O1, it is equals to A plus C1. So let's continue. O1, which is this one, right? So O1, it is equals to angle A plus and what? C1. This one and this one, they are equals to that one. What is the reason, guys? Exterior angles of a triangle. X angle of a triangle. You see? O1, it is equals to A plus C. And it is something like this. Okay? Okay. I hope you get it. So, therefore, O1, it is equals to 2 times C2. Okay? O1, it is equals to 2 times what? C1. And I'm still using C1. So O1, it is equals to 2 times C1. O1, it is equals to 2 times C1. So similarly or whatever, for this triangle, I'm gonna do this. O2, it is equals to 2 times C2. So O2, it is equals to 2 times C2. And then I'm gonna continue. I'm gonna combine everything. So it's gonna be O1 plus O2. It is equals to what? 2 times what? Remember that I said O2, it is equals to 2 times C2, right? So it will be angle O1 plus angle O2. It is equals to 2 times C1 plus 2 times C2. Yeah, but these are the angles, right? And then manje I'm gonna continue. What is O1 plus O2? It is what? AOB. AOB. Because O1 and O2, it is what? AOB. It is now equals to what? I'm gonna factor out 2, which will be 2 times C1 plus C2. And then which will be equals to what? Which will be the same as AOB, which will be equals to, what is C1 plus C2? C1 plus C2, it is the angle which is what? C. So it is the same as 2ACB. Proven. So this is how we prove. The first thing that you must do, you must construct a vertical line, dots, because you are required to prove that AOB, it is 2 times AOB, it is 2 times ACB. So you construct there, and then you know with your OA, it is equals to your OC, which is the radi, line from the center to the circumference, and then my angle A, it is equals to C1, opposite angles, equal sides. And then O1, it is equals to A plus C1, which is exterior angles of a cyclic quad, exterior angle of a triangle. And then O1, it is equals to 2 times angle C1, because O1, it is equals to angle times 2 times C1. Similarly, O2, it is what? Equals to 2 times C2. And then manje, I'm gonna add the two things there, which are gonna give me the answer, just like that, guys. I hope you understand everything. This is the most examined question that they like to answer, to question you in the exam. So you just have to know everything that is there. Okay, I hope you enjoyed, guys. Thank you.